Hello Chem 1. Today we're going to show the last way that you can use a graphic organizer to represent the electrons of an atom. Let's get started with Lewis structures. You may remember in physical science class using Lewis structures or electron dot diagrams to show just the valence electrons of any atom. For instance, we know that everything in the first column of the periodic table has one valence electron. Everything in the second main group column has two. Now you know that because you know that everything in the first column ends with S1, 1s1, 2s1, 3s1, 4s1, and so on. You know that everything in the fifth main group column, the nitrogen family, ends in P3, 2p3, 3p3, 4p3, all the way down. So everything within the column on the periodic table has the same number of valence electrons, and it'll also have similar physical and chemical properties because of this. So today we're going to kind of reteach you Lewis structures or electron dot diagrams a little differently. Here's the thing that's a little different. You know now that electrons around any element, let's say we'll call it element X, don't get placed like this. You know that those first two electrons are going to be together in the S sublevel. So a lot of times we think about those electrons at the top of the Lewis structure. And then after you fill the S sublevel, you fill the p orbitals, and there's 3 p orbitals within that sublevel, which are the 3 other sides of the element. So we want to fill Lewis structures in a way that's representative of the electron configuration notation, meaning the first 2 electrons should always go at the top, and then we want to spread out the other 6 potential electrons as far as we can. So if we look at lithium on the periodic table, it's in the first column, so it only has 1 valence electron, and we're going to put it at the top. Magnesium has 2 valence electrons, and they're both going to go at the top in the S sublevel. Aluminum has 3. The first 2 will go at the top, and then I like to go clockwise to the right as I place the other electrons. Tin has 4. Once again, the first 2 go in the S sublevel at the top, but then we want to represent Hund's rule correctly. So the next 2 are going to be spaced out. One will go on the right, and one will go on the bottom. They can't occupy the same orbital yet because the P sublevel isn't full. Arsenic has 5. The first 2 go at the top in the S sublevel. Then we spread the next 3 out. Sulfur has 6. So we spread the next 3 out, and then the 6th one will go back over here to the right to pair it up in the first p orbital. Fluorine has 7. So I go 1, 2, 3, 4, 5, 6, 7. And then argon has 8, which means there's 2 on every side. Another way to think about this is the order that you place electrons. I always put the first electron here, the second one here, then I put 3, 4, 5, 6, 7, and 8. And if you always fill electrons in that order, you'll make sure that they're always in the correct position. Once again, this is going to take practice. Do the activity. Make sure you understand how this model relates to the electron configuration notations in the orbitals that we've talked about so far. This is the last note day for Unit 4. Practice these things. Get good at them. Be able to see them in your sleep. Good job. We will see you next time.